Welcome to Tech Unplugged podcast.
It's great to be here.
Today, we're going to be diving deep into the world of AI security.
Yeah.
You've shared some really fascinating material with me, and our mission today is to unpack all of this, What does all of this mean for our listeners out there, whether they're, tech professionals, business leaders, or just someone who's really interested in, staying safe in this age of AI. So we're going to be exploring some of the unique risks that come with using AI, how security experts are tackling these challenges, and what our listeners should really be aware of to protect themselves and their organizations. So no need to feel overwhelmed. We're going to be extracting the essential insights that you need right now.
Yeah, sounds good. I think a lot of people, when they hear AI risk, kind of lump it all into one big bucket. But it can be really helpful to think about AI risk in two distinct categories.
Yeah.
Safety and security.
Okay, so safety first, right? What does that mean when we're talking about AI?
Yeah, so AI safety is all about making sure that the AI model itself, like the actual model, isn't producing harmful or unintended outputs.
So like what kind of things are we talking about here?
Well, think about biased results, for example.
Okay.
We've seen AI generate really weird visual representations or even data that reflects biases that were present in the information it was trained on.
Oh, I see.
And here's the thing. This isn't always about developers intentionally creating a biased model.
Right.
It often comes down to problems with the training data itself. Maybe it overemphasizes certain viewpoints, or maybe it doesn't include a diverse enough range of information to be truly representative. Kind of like the old saying, garbage in, garbage out.
Makes sense. So how does security differ from safety when it comes to AI?
So with AI security, we're taking all of those concepts that we've learned from traditional cybersecurity over the years.
Right.
Things like protecting our networks and applications.
Right.
And we're applying them to the unique challenges that AI brings to the table. What's interesting here is that when you're actually testing an AI system's defenses, something that we call red teaming, it's not always the same as your typical penetration test.
How so?
Well, you have to really dig deep and understand what the client is most worried about. Are they concerned about a customer-facing chatbot? Or is their concern more about critical infrastructure that's powered by AI? Each scenario demands its own very specific approach. So when you're trying to assess AI risk, you can just look at how the AI behaves. You also need to look at the security of the entire infrastructure, all those data pipelines that surround it. It's a two-pronged challenge.
That distinction between safety and security is really useful. Now, you mentioned red teaming. What kind of vulnerabilities are security experts actually finding when they're poking and prodding these AI models? I keep hearing about this thing called data poisoning.
Yeah, data poisoning is a big one, and it's the legitimate concern. Imagine this. Someone intentionally injecting bad data, malicious data, into the massive data sets that are used to train these very large AI models, the ones that we call foundation models.
Right.
These foundation models are trained on information that's scraped from huge portions of the internet, including things like online forums and code repositories.
Wow.
So if an attacker is able to slip in some of this poison data, and if they know that it's there, well, they might be able to retrieve that data later. Or even worse, they could manipulate the model's behavior by using really carefully crafted prompts. And that's a big problem. You can see how that could be exploited, right?
Yeah, that's scary.
Yeah. And here's the thing. The integrity of an AI's knowledge base is directly tied to the security of its training data supply chain. And that's a risk that we don't really see in the same way with traditional software.
There's like a whole new level of vulnerability then. And what about this indirect prompt injection?
Yeah, so indirect prompt injection, that's another sneaky one. Imagine using AI, let's say a large language model, to create these super convincing phishing campaigns. Think back to all those old phishing emails we used to get, the ones with all the obvious mistakes, the bad grammar, the weird formatting. AI can make all of that go away. It can make phishing attacks way harder to spot. But here's where it gets even more worrying. If an attacker can actually get their hands on someone's login credentials, and those credentials belong to someone who works at a company that uses internal AI models, well, that attacker now has access to this super powerful assistant. It's like having a sidekick that can dig into all of the company's proprietary data.
So it's like they've basically given a hacker an AI assistant.
Exactly. And if that AI has what we call agentic capabilities, meaning it can actually use tools and do things within the company's systems, well, then that's a huge risk, an immediate risk.
That paints a pretty alarming picture.
It does. And it's really important to grasp the difference between, let's say, a researcher demonstrating a data poisoning trick in a lab setting
Uh-huh.
and the very real threat this poses to organizations. What might seem like just a fun experiment could actually be setting the stage for much more complex attacks.
Hmm.
These nested attacks where if an attacker gets even a tiny foothold, well, they might be able to completely take over an organization's systems. It's that serious.
Now, you've mentioned agentic AI, and you've talked about these persona prompt patterns. Can you explain what those are?
Sure. So when we talk about persona prompt patterns, we're basically describing a technique where you give an AI a specific role to play. You set up some boundaries within your prompt.
Okay.
For example, you might tell an AI to act as a seasoned cybersecurity expert and explain this vulnerability in detail. You're giving it a persona to adopt. People are even using coding personas, where they give the AI really strict rules about what kind of code it's allowed to generate. Like they might say, you can only write code that's well-documented, verified, and comes from trusted sources.
Yeah.
It's like giving the AI a hat to wear during that particular interaction.
So it's like giving the AI a very detailed job description.
Exactly. You're
Yeah.
setting expectations. But, and this is crucial, even when you use these fancy personas, you have to remember that AI systems are still what we call non-deterministic. That means that you might get slightly different answers or results each time, even with the same prompt.
Oh, interesting.
So while personas can definitely make things more predictable, they're not a foolproof solution.
Okay, good to know.
And just to clarify, when I talk about agents, I'm talking about something more advanced. I'm talking about AI systems that can plan and carry out tasks over time.
Hmm.
They might use tools, interact with different systems. That's a whole other ballgame, and that technology is still very much under development.
So this whole idea of controlling the information that these AI models learn from and then generate, that raises some important questions.
It does, and what I find really fascinating is the parallel between this and the idea that if you control information, you can control what people think. We've seen that explored in literature. We've seen it in history. And today, we see accusations being thrown around about how search engines and social media platforms might be manipulating the information we see.
It makes you think.
It does. And AI can be influenced in the same way. Whoever controls and prepares the data that's used to train an AI, they have a lot of power. And that has big implications for what we consider to be true, what we consider to be accurate. That's why it's so important to have human oversight of AI outputs. It doesn't matter what you call it, human in the loop or human at the helm. The point is, you can't just blindly trust everything that an AI spits out.
Right, you've got to have someone checking its work.
Absolutely. Even if the AI is using your own internal data, there's this technique called retrieval augmented generation, RAG for short, where the AI pulls information from your knowledge base to answer questions. Even then, you still need to double check. You can't assume it's always going to be 100% right or unbiased. Humans are still essential.
So with all of these potential vulnerabilities, how do you actually go about finding and fixing security issues in AI systems? Do you have any real-world examples of what this looks like?
Yeah, absolutely. I was actually involved in a red teaming project for a really big organization. And what was interesting about this particular project was that it was highly confidential. We had zero direct communication with their developers or their security teams. But even without talking to them, we could tell that they were addressing the vulnerabilities we were finding. We could see that the model's behavior was changing every day as they implemented fixes based on what we were uncovering.
So you're basically playing this cat and mouse game with their security team.
Kinda, yeah. And it was really cool to see that our work, even though it was behind the scenes, was having a real impact. It just goes to show you how important proactive AI security work is.
It sounds like a real detective story. Now, how does this AI red teaming compare to the traditional kind of red teaming that people might be more familiar with?
Yeah, there are definitely some overlaps. In both cases, you're trying to find weaknesses in a system's defenses. That's the core idea. But with AI red teaming, there's often more of an emphasis on trying to understand how the model behaves. You know, can it generate harmful content? Can it be tricked into saying things that are biased? How does it respond to weird inputs? Traditional red teaming, on the other hand, might have a broader scope. They might be looking at things like network vulnerabilities, physical security, even social engineering tactics. It really depends on what the goals are for that particular engagement.
So let's circle back to that safety versus security distinction. It seems like they're tackling different aspects of the overall risk picture when it comes to AI.
Exactly. Think about it this way. AI safety is all about the model file itself, how it works, whether it spits out bad stuff.
Okay.
AI security, though, That's about the bigger picture. It's about the entire ecosystem that the AI lives in.
Got it.
So that includes all the networks it connects to, all the applications that are built using the AI, and even the entire process of developing that AI. That's where MLC COPS comes in.
MLC hops.
It stands for Machine Learning Security Operations. It's basically about making sure that security best practices are baked into how machine learning models are developed, kind of like how DevSecOps works for traditional software.
Okay, makes sense.
So if you're a company and you're building a chatbot or an AI-powered agent, well, your software engineers need to be thinking about security right from the very beginning.
And it's not just about the code that a company writes themselves, right?
hmm
They could also be introducing risks by using AI models or data that come from other places.
That's a really important point. It's all about the source. Where did you get your AI models from? Where's your training data coming from?
hmm
If you just download a pre-trained model from a site like Hugging Face, well, you don't know for sure if it's secure.
That's kind of worrying.
It is. And it's actually only very recently that Hugging Face teamed up with a company called Protect AI to start scanning their models for malicious code. That tells you something, right? People are starting to realize just how risky this AI supply chain can be. But here's the thing. Even with all this scanning going on, there's still no guarantee that a model is completely safe.
So it sounds like we need a totally new way of thinking about application security in this age of AI.
Absolutely. We're talking about a whole new field here, AI application security.
Hmm.
Traditional app security that was designed for deterministic software, the kind of software where you put in the same input and you get the same output every time. But AI models, especially the ones that can create stuff, the generative ones, they're often non-deterministic. You can give them the same prompt over and over, and you get different results.
Yeah,
So we need new ways of figuring out where the weaknesses are and how to fix them.
I see.
And here's another wrinkle. AI applications, they can keep learning, they can change even after you've launched them.
Oh, wow.
So you might end up with vulnerabilities or weird behaviors that you'd never see in traditional software. It's a whole different ballgame.
So when we talk about AI application security, what are some of the vulnerabilities that we're concerned about? What are we actually looking for?
Well, the list is long, and it keeps getting longer. On the safety side, we're worried about AI that might generate toxic content, stuff that's offensive or inappropriate. We're worried about AI that might leak sensitive information. And of course, there's the whole issue of malicious use. Could someone use AI to do bad things? We're also concerned about deception and manipulation. Could AI be used to trick people? And then there are the broader social implications. Could AI be used in ways that harm society?
That's a lot to think about.
It is. And then on the security side, we have things like prompt injection, where someone tries to hijack the AI by feeding it carefully crafted prompts. This could be direct or indirect. We have data poisoning, where someone tries to corrupt the AI's training data. And then there's jailbreaking, where someone tries to break out of the AI's safety controls. And then there's the whole issue of privacy attacks. Could someone use AI to spy on people or steal their data?
So it's a complex landscape, to say the least. Given all of these potential threats, how do organizations even begin to approach securing their AI systems? Where do they even start?
The key is to shift left. That means that security needs to be part of the conversation right from the very beginning of the AI development process, not just an afterthought.
Okay.
So that means you need to be really careful about where you're getting your training data from,
Yeah.
where you're getting your pre-trained models from. Are these sources trustworthy?
Makes sense.
And you should be scanning these models for any signs of malicious code, any signs of unsafe behavior. And here's something that might surprise you. Even if you're taking a good foundation model, one that's been carefully vetted, and you're tweaking it for your specific needs, you still need to check it. You still need to validate it for both security and safety.
Why is that?
Because sometimes when you tweak a model, you can accidentally break the safety features that were built into the original model.
Oh, wow.
Yeah. And to do this validation, you often have to use an API. That's basically a way of interacting with the model without actually seeing its guts. It's like a black box.
I see.
And you should be doing this validation every single time you update the model. It's an ongoing process.
Okay, so you've built your AI, you've checked it for vulnerabilities, and now it's out in the wild. How do you keep it secure once it's actually being used?
Constant vigilance.
Yeah.
You have to be on the lookout for any new vulnerabilities that might pop up, and you have to keep up with the latest threat intelligence. What are the bad guys doing these days?
Right.
And here's the thing. With traditional software, you can often just patch a vulnerability, release an update. But with AI, it's not that simple. You can't just slap a Band-Aid on it. You have to think about controls.
Controls.
Yeah, like an AI application firewall, for example. This is something that can block bad requests from getting to the AI, and it can stop the AI from generating responses that are unsafe. And all of the logs from this firewall that can be fed into your other security systems so that you can track what's going on and respond to incidents.
It sounds like AI itself is also becoming a valuable tool in the cybersecurity world.
Oh, absolutely. AI is being used more and more to help organizations improve their security posture. We're seeing things like machine learning and deep learning being used to analyze huge amounts of data. Things like network traffic, how applications are being used, even browsing habits.
Right.
And by looking for patterns in this data, AI systems can spot anything unusual that might be a sign of a security threat. We're even seeing generative AI being used to take all of this complicated security data and translate it into plain English. So instead of having to decipher all of these technical logs and reports, security teams can get clear, actionable recommendations. And studies have shown that companies that really embrace AI and automation, well, they can detect threats and respond to incidents much faster.
It sounds like AI is becoming a real game changer in cybersecurity.
It is. But it's not a silver bullet. Like any powerful tool, it can be used for good or for bad.
So it's a double-edged sword.
Exactly. While AI can make us more secure, it can also be used by attackers to make their attacks more sophisticated, more targeted. Things like highly personalized phishing campaigns. And, of course, the AI models themselves are new targets. Attackers are looking for ways to exploit them, to manipulate them.
So it's like a constant arms race.
It is. Now, shifting gears a bit, let's talk about data privacy. How does the rise of AI impact our privacy? The EROSP AI Security and Privacy Guide does a great job of highlighting the growing concerns in this area. One really important principle is use limitation and purpose specification. Basically, what that means is that if you collect data for one specific reason, you shouldn't use it for something completely different.
So if you're collecting biometric data for multi-factor authentication, you shouldn't be using that same data to build a marketing profile.
Exactly. That would be a violation of that principle. And a lot of data privacy regulations, like GDPR, they require you to have a clear legal basis for processing personal data.
Makes sense.
And there are some AI practices that are considered so risky that they're being restricted. Like in the EU, they're working on the AI Act. And one of the things that it does is ban the use of AI for individual criminal profiling.
Oh, wow.
Yeah. And it's not just about personal data. Even how you use non-personal data can be problematic. It can lead to unfair or harmful outcomes if you're not careful. That's why we're seeing new techniques being developed, things like data enclaves and federated learning, which are designed to give you more control over how data is used.
Fairness in AI is another big topic these days.
It is. And fairness, when we're talking about AI, means that you're handling data in a way that people would expect, in a way that's reasonable. And it means that you're not discriminating against certain groups of people.
Okay.
And here's an interesting point. Even if your AI model is accurate, it can still lead to privacy problems.
How so?
Well, imagine you have an AI system that's designed to detect fraud. And it's really good at its job, it's very accurate, but what if it makes a mistake? What if it flags someone as a fraudster when they're not? That could have a huge impact on that person's life. It could affect their credit score, their ability to get a loan, all sorts of things.
That's a good point.
So accuracy is important, but it's not the only thing that matters. You also need to think about fairness. And there are lots of different ways to measure fairness in AI, but there's no one-size-fits-all solution. It's often a balancing act. You're trying to make your AI as accurate as possible, but you also want to make sure that it's not discriminating against anyone.
And sometimes you might have to accept that you can't achieve both goals at the same time.
Exactly. Sometimes the most responsible thing to do is to say, you know what, this AI model is too risky, we're not going to deploy it.
So given the huge amount of data that AI models are trained on, what does that mean for our privacy?
That brings us to data minimization and storage limitation. Basically, the idea is that you should only collect the data that you absolutely need, and you should only keep it for as long as you need it.
Okay, less is more.
Exactly. And whenever possible, you should anonymize the data. And that doesn't just mean removing someone's name and address. You might also need to remove other identifying information. And sometimes you need to reduce the level of detail in the data. You might not need to know someone's exact age. Maybe you just need to know their age range.
I see.
And once you've finished using the data, you should delete it. And you should restrict access to the data. Not everyone in your organization needs to be able to see everything.
Right, need to know basis.
Exactly. And there are also some really cool new technologies being developed, like distributed data analysis and secure multi-party computation. These allow you to analyze data without actually having to see the raw data itself.
That sounds pretty amazing.
It is, and it has huge implications for privacy.
Transparency is another big issue when we talk about AI.
Absolutely. Transparency is all about building trust. If people don't understand how AI is being used, they're not going to trust it.
Makes sense.
And a lot of data privacy regulations, like GDPR, they have specific requirements for transparency. You have to tell people how you're using their data. You have to give them a copy of their data if they ask for it. And you have to tell them if you make any major changes to how you're processing their data.
Right, keep them in the loop.
Exactly. But transparency isn't just about the end user. It's also about internal transparency. Your own employees need to understand how AI is being used.
Okay, so good documentation is important.
It is. And you need to be able to track how decisions are being made. If an AI system makes a decision, you need to be able to explain why it made that decision. And that explanation needs to be understandable to humans, not just to other AI systems.
So it's about accountability as well.
Exactly.
Now, individuals have certain rights when it comes to their personal data. How does AI affect those rights?
Yeah, so these are often called privacy rights, and they give people more control over their own data.
Like what?
Well, for example, you have the right to access your data. You can ask a company, hey, what data do you have about me? And they have to tell you.
Okay.
You also have the right to data portability. That means you can ask a company to give you a copy of your data in a format that you can use.
So you can take your data with you if you switch to a different service.
Exactly.
Yeah.
And then there's the right to erasure, also known as the right to be forgotten. You can ask a company to delete your data.
Interesting.
And you have the right to correct any inaccurate data. If they have your age wrong, your address wrong, you can ask them to fix it.
Makes sense.
And you also have the right to object to the processing of your data for certain purposes.
So if you don't want them using your data for marketing, you can tell them to stop.
Exactly. And this is all really important in the context of AI because AI systems are often trained on huge amounts of personal data. So you have to think about how you're going to respect these privacy rights.
And that might mean retraining your AI models if someone asks you to delete their data.
It could, yeah.
Data accuracy is another big issue when we talk about AI and privacy.
Absolutely. If your AI systems are making decisions based on inaccurate data, well, that can have serious consequences for people.
Right. Wrong data, wrong decisions.
Exactly. And those decisions could be about anything. It could be about whether someone gets a loan, whether they get hired for a job, whether they get approved for insurance. So it's really important to make sure that the data you're using is accurate and up to date.
And that means having processes in place to check the data, to correct any errors, and to make sure that you're getting your data from reliable sources.
Exactly. Garbage in, garbage out, right?
Right. And finally, there's the issue of consent. How does consent play into all of this?
Consent is all about giving people a choice. Do they want you to use their data or not? And a lot of data privacy regulations, like GDPR, they say that you need to get consent before you can use someone's data. But that consent has to be freely given. It can't be coerced. And it has to be specific. You can't just say, hey, can we use your data for anything we want?
Right. You have to be clear about what you're going to use the data for.
Exactly. And the person has to understand what they're agreeing to.
So no burying it in a long, complicated privacy policy that nobody reads.
Right. And the consent has to be easy to withdraw. If someone changes their mind, they should be able to say, hey, I don't want you to use my data anymore.
And then you have to delete their data.
Right. Ideally, you should also retrain your AI models so that they're not using that data anymore.
Now, we talked earlier about all of those security threats that AI systems face. How do those threats relate to privacy?
So this brings us to model attacks. Basically, if someone can hack into your AI system, they might be able to steal the data that the AI is trained on. And if that data is personal data, well, that's a privacy violation.
Right. It's a data breach.
Exactly. And there are all sorts of ways that attackers can try to steal data from AI systems. They might try to figure out if a particular data point was used to train the model. They might try to reconstruct the training data from the model itself.
It sounds pretty sophisticated.
It is, and it's a real concern.
So how can companies protect themselves against these model attacks?
It all comes down to good security practices. You need to have strong encryption in place. You need to control who has access to your AI systems. And you need to be constantly monitoring for any signs of intrusion.
And you need to be aware of the different types of model attacks that are out there so that you can defend against them.
Exactly.
Now, switching gears again, you mentioned earlier that how AI models are stored and shared can introduce vulnerabilities. I've heard about this thing called pickle. Can you explain what that is?
Yeah, so Pickle is basically the default way that Python programmers save their AI models. It's like putting the model in a jar so that you can store it or share it with others.
Okay.
But Pickle has a bit of a security problem. Yeah, the way that Pickle works, it allows you to embed code inside of the model file. And when someone loads that model file, that code gets executed.
So if an attacker can sneak some malicious code into a pickle file, they can potentially take over someone's computer.
Exactly. It's called remote code execution.
That sounds bad.
It is. And it's a real vulnerability. Now, to be fair to Pickle, this isn't necessarily a problem if you're only ever loading Pickle files that you've created yourself or that you've gotten from a trusted source.
Okay, so it's about trust.
Exactly.
Yeah.
But if you're downloading models from the internet, you need to be very careful. You don't know who created those models. You don't know if they've been tampered with.
So what can you do to protect yourself?
Well, the best solution is to use a different format for saving your models. There's a format called safe tensors that's designed to be more secure.
Okay.
But if you have to use Pickle, then you need to be extra vigilant. Only load files from trusted sources. And if you come across a model that you think might be compromised, report it to the creator or the maintainer of that model.
Makes sense. So considering all of these complexities, all of these potential threats, what does a good AI security solution look like? What should organizations be doing to protect themselves?
Well, ideally, you want a comprehensive AI security platform, something that can give you visibility into all of your AI systems, that can help you find and fix vulnerabilities, and that can help you set up good governance policies.
So it's not just about technology, it's also about processes and policies.
Exactly. And you need to start thinking about security from the very beginning of the development process. Secure by design, that should be your mantra.
Secure by design, I like that.
And you need to have good testing procedures in place. You need tools that can specifically test AI applications.
Right, because traditional security tools might not be enough.
Exactly. And you need to be thinking about your supply chain. Where are you getting your components from? Are they secure?
Right, it's all connected.
It is. And OWASP, they have a really helpful resource called the Top 10 for large language model applications. It's a great starting point for understanding the most common vulnerabilities.
So organizations need a strategy, a plan for how they're going to secure their AI systems.
Absolutely. They need to figure out what their risks are, what their needs are, and then they need to put the right solutions in place.
And that includes training their employees.
Absolutely. You can have the best technology in the world, but if your employees don't know how to use it securely, well, it's not going to do you much good.
It's the human factor.
It is. And here's an interesting development. AI itself is being used to make traditional security tools better.
Oh, really?
Yeah. So you're seeing things like AI-powered static analysis tools, AI-powered software composition analysis tools. These tools can provide more intelligent analysis. They can give developers real-time feedback. They can even suggest safer ways to write code.
So AI is making security tools smarter.
Exactly. But we also need to be careful about bias.
Bias in the AI tools themselves.
Yeah. If the AI tools are trained on biased data, well, they might perpetuate those biases. So that's something that we need to be mindful of.
That's a good point.
And we're moving towards this idea of adaptive application security. That's basically about having a unified view of your entire IT environment, all of your code, all of your cloud infrastructure. And it's about integrating security throughout the entire development lifecycle.
So it's a more holistic approach to security.
Exactly. And some people believe that we'll eventually be able to use AI to automate a lot of the security tasks that are currently done manually.
Oh, wow. So AI could potentially fix code vulnerabilities automatically.
That's the idea.
That would be pretty amazing.
It would. And of course, you also need to secure the AI systems themselves.
Right, so it's not just about securing the applications that use AI, it's also about securing the AI infrastructure.
Exactly. You need to have strong encryption in place. You need to have access controls. You need to be monitoring for threats. And you need to be constantly evaluating your AI systems to make sure that they're performing as expected, that they're compliant with regulations, and that they're not introducing any new risks.
So it's a multifaceted challenge.
It is.
Now, what about all of those companies that provide managed security services, the MSPs? How do they fit into this AI-driven world?
That's a good question. And it's one that a lot of people in the industry are asking right now. We're seeing some new companies pop up that are basically saying, hey, we can automate all of your security operations using AI. You don't need an MSP anymore.
So they're trying to